Now, we would like to take a pause in your analysis to answer one question that has been raised by you already, which is what happens if we have highly correlated indicators? This presentation builds upon the work of Sabina Alcar and Paola Bayón, and it's called Association Across Deprivations. Please note that we are using the word association instead of correlation. Would anyone have a hint on why is this the case and why we are not naming correlations? Yes? Mm-hmm. Yes, absolutely. So we are talking about categorical variables, or perhaps with an order, ordinal variables, or with categories that we then recode into 0, 1 dummy variables. But we cannot assume that there is going to be a linear relationship between them, and we are not, more importantly, we are not analyzing this relationship in the framework of an economic model. So we would like to use the term associations, which is a broader term to define relationships of between indicators without putting them into a framework of an economic model. Now, the objectives of this session or of this lecture is first to give you tools to define whether the relationship between indicators it's high or low, its strength, its direction, probably positive or negative. Also to bring upon some idea about the similarity between indicators and ways to assess its redundancy. And at the same time, give you a framework to use these tools in order to make normative decisions, such as the weighting of the indicators themselves to include in your measure, and how to group them in categories known as dimensions. So some of the things that you may do with these tools is, for instance, drop or modify the weights of highly correlated indicators, combine some indicators into a subindex, or adjust your categorization of indicators into dimensions. Now, it's very important to say as well that these tools are only a complement, a supplement into your toolkit with which you will take normative decisions. Remember, please, that normative decisions are not only based on one piece of information, in this case, for instance, an empirical relationship between two indicators, but they are also based on value judgments, constraints, considerations of political constraints, for instance, and this is something that you should bear in mind. So this is only a tool into the process of decision making. Now, it's useful to revise the literature to know what the authors have said about relationship between indicators, and some of them, Paola and Sabina have grouped them into those who favor, or those who seem to favor, a high association between indicators. This is basically more frequently to observe when they are combining indicators into a measure that it's composed by marginal distribution of indicators. If you remember, we have discussed that some of the measures that combine marginal distributions are the HDI and the HPI. And the reason why they argue that high correlation is good to have into this composite index is because, well, probably it makes sense that if one indicator is going in one direction and another indicator is going in a very different direction, the distribution may be orthogonal, and it may be very difficult to combine such thing into a single indicator, as opposed as when you have indicators that move in the same direction, whether it's positive or negative, but they are giving you the same piece of information or pointing you towards the same kind of information. So they argue that high association between indicators is actually good for having a robust measure. Why they would think that it would be a robust measure? Well, basically, if indicators are highly associated inside the index, if you take one out, then you probably don't expect that the measure will change much. So no indicator or no piece of information is very much essential into the combination. So some of the authors that have argued this or that have shown this is the case is, for instance, the OECD Handbook of Composite Indicators that it's quite widely used in social sciences, and also James Foster, McGillivan, and Seth in their book. Now there is another stream of literature that favors low association, and this is the case when they think that very high correlation signals redundancy. That is, that if I have the pieces of information that only point to the same direction, I probably am just capturing one form of this concept that I want to measure, and I'm not capturing other forms of this same concept. So they would say that actually highly associated indicators shouldn't be included in the same index, and some examples in the literature are Rani, Saman, and Stewart. So Office stands not in one or the other position. As I mentioned, the first thing that you should be aware is that you will always face the dilemma of having a robust measure in which indicators point towards the same direction, but at the same time having the argument for multidimension, that is capturing as many aspects of poverty as possible, and also fearing the fact that your indicators may be redundant inside your measure. And more importantly, we would like again to emphasize that the decision making around indicators is normative. So not only an empirical relationship should inform your decision making, but also value judgments, and then probably if you have highly correlated indicators, you may still want to keep them if there are different policies that they represent into the index and that you would like to measure them, or if the indicators have a low association, you may still want to keep them because they are independently important regardless their empirical relation. Now, before looking at the examples, well, first the concepts on how we are going to assess this relationship, I would like to describe the limitations of the data that we are going to analyze, and which also signals the limited scope of these tools, but that could be certainly applied into further cases. Firstly, we will focus again on dichotomic variables 0, 1, but most of these indices or coefficients, better said, can be applied to multiple categories as well. Obviously, the formula would change, but the coefficients most of the time can be applied to different categories. We will also focus on the joint distribution. So we are not in this lecture. We are not concerned about the association of marginal distributions. Probably this will be more clear when we go to the examples. And I will present only examples with uncensored headcount ratios and uncensored data. But you can always incorporate the notion of poverty and follow up with censored headcount ratios. So again, the idea of this class is to introduce you to a concept of or a definition of association, and then points the limitations and the argument for another coefficient, which is redundancy, a measure that of similarity or overlap. So what is the difference between association and similarity? It's probably important to signal that association defines the strength, whether it's high or low, the relationship between two indicators, but also the direction, whether it's positive or negative. Similarity only focuses on a positive relationship. That is, when both indicators point towards the same direction, that is, when both indicators are identifying a person who is deprived in both indicators. So this is the positive matches of both indicators. And there is a long list of coefficients to measure these concepts. Actually, for instance, in 1982, Hubalek identified 43 different coefficients to measure these concepts. Coefficients of clustering, simple matching coefficient, Jaccard coefficient. We will focus only on two of them, one for each. And we will also, in this session, we won't be talking about some of the methods that you also raised in the first session. I remember some of you were asking about principal component analysis, factor analysis, clustering and analysis. But we won't be touching upon them, but some of them actually build upon the same ideas, which is the analysis of the contingency table, which is our next slide. Well, the next to the next one. First, I would like to just pose an example of the NFHS survey data for India. We know that the raw headcount ratio for child mortality in this dataset is 22.6%, and the raw headcount ratio for schooling is 17.6%. And we want to know the association or the relationship between these two deprivations. What's the overlap? Well, I don't know if this could be straightforward for many of you, but only 5.8% of the people in the society experience both deprivations at the same time. The rest of them experience either one or the other. And this is less than a third, less than 1/3 experience the same deprivation. Obviously, depending on which headcount ratio you take as a reference. We will talk about that in a couple of slides. So if we have a look at the contingency table across tab of two dichotomous variables, safe water and child mortality, safe water on the rows and child mortality on columns, we see that the raw headcount ratio and marginal distribution of child mortality is 5 of 10 people, so it's 50%. And for safe water is 4 of 10 people are deprived, which is 40%. The formal notation of the marginals are N0 plus N1 plus for safe water, and N plus 0, N plus 1 for child mortality. And the table also shows us the joint distribution. So for the joint distribution, we have the matches of these two indicators. The matches is the cases in which they are pointing in the same direction. So 0, 0, it's people that are non-deprived in any of the indicators. And it's the number of percentage of people who are not deprived, and 1, it's the percentage of people who are deprived in both indicators, either the number or the percentage, depending on how you are looking at the table. The mismatches is when they are deprived in one but not the other, and that is also represented in the table, as well as the marginal distributions as we saw. So what a traditional measure of association would do is to show the affinity that is between two nominal or dichotomous variables in a single number, which is a coefficient that summarizes or that synthesizes this measure of strength and direction. And most of the coefficients that measure associations, such as lambda, the uncertainty coefficient, and the Kramer bias, we will see, as well as the one that we are going to be using, describing later, measure the axis of association as independence. And they base this test, this hypothesis test using the chi-square statistic. So what would an independent distribution would look like based on our previous table? Again, we see 10 people in this society, and we see the marginal distribution of child mortality of 5. Now, Save Water has a marginal distribution of 5 as well, and an independent distribution is joint distribution is given inside the table, 2.5 in each of the cells. Now, obviously, this is a made-up example because you wouldn't see 2.5 people. You would have to see either 2 or 3. But I wanted to raise this because we would rarely see independent distributions among variables. So the coefficient that we want to propose for describing this association is the Kramer V, and it's very powerful because it's bounded between 0 and 1. And also it has the signal being positive or negative. So if it's 0, it shows the absence of relationship. If it's -1, it shows the perfect association in the negative direction, and if it's +1, it shows the perfect association in the positive direction. And this is very powerful because it can be interpreted easily. Now, for some of you, you probably recognize the formula. Probably I should just quickly go back without showing the last bit of the slide. The formula is based on the crosstab, and it actually is showing the product of the matches, that is the product of non-deprived times deprived, n not times n11, minus the product of the mismatches, those that are depriving one or the other, over the square root of the margins. And then some of you probably recognize these that could be seen as the determinant of a matrix. And actually for 0, 1 variables, Kramer V is very useful because it's similar to the correlation coefficient that we would normally see again in an economic model framework that is analyzing continuous variables, cardinal measures that can be inferred to be correlated. So both measures could be seen as the percentage of maximum possible variation between two variables. Now, are there any? Well, no, I will continue with for a couple of slides of Kramer B, and then if there are any questions before continuing. Well, one of the limitations of the association is probably the fact that they use all of the information of the contingency table. They use the marginal distribution of each variable. They use the matches of both matches and the mismatches. So in our formula, we see that matches, mismatches, and marginal distribution are used, which we know that identifies the overlap of deprivation, that is the positive matches, when a person is deprived in both indicators, which is key in the framework of the Alcar-Foster method. But it also contains information of the mismatches and the marginal distributions, which we argue that dilutes the information about the overlapping deprivations. And this is why we propose a second measure or a second coefficient to analyze this relationship. So the measure of redundancy, because we are expecting to see two indicators of deprivations that are not independent. That is that, again, they are not going in a very different direction one way and the other one in another way. And when we are also expecting to see marginal distributions larger than 0 or positive in at least of them. So at least someone would be depriving one of the indicators. Then we are proposing the measure of redundancy, which again assesses the deprivation, the coupled deprivations or deprivation in both indicators, and it puts it into the context of the minimum of the marginal distribution. So in terms of notation, N11 indicates the people who are deprived in both indicators, and N+1 and N1+ are the marginals. Now again, redundancy reflects the strength of the matches, but not direction. Why not direction? Because we are actually talking about positive direction, is when both show the same direction, which is that they are deprived in both. So it's always about positive direction. And we think this is very powerful because we are interested in those who are experience overlapping deprivations, deprived in two indicators at the same time. Now if we go back to the original contingency table, the matching or the matching deprivations are shown in the bottom right corner, which is number 3. So 3 people are deprived in safe water and at the same time in child mortality. Now, why I have to put this into a context of level of poverty? Because I want to know, first, it's 3 in a population of 10, but secondly, it's 3 in a possible number, well, the highest possible number of 4. Why do I say that the cell that has number 3 can reach only a maximum possible of 4? Do you have any idea why? Well, probably because I'm just saying that there are only 4 people in the society that are depriving safe water. So if there are 4 people that are depriving safe water in the society, and there is and the 6 of the remaining people are non-deprived in safe water, then the maximum number that I can have overlapping with child mortality, it's 4, because they would be deprived. They would all be deprived in child mortality at the same time. Does this make sense? Yes? Yes, great. I'm glad to see heads nodding, because this is the reason why we also we also express this as in the minimum of the marginal distribution. This is why we divide for the coefficient of redundancy. This is why we divide 3/4 instead of 3/5. So if we have like the maximum possible of overlapping deprivations, which is 4, and we know that the minimum of the marginals is 4, then the redundancy, you see, that would be 1. And that is the highest value that redundancy could reach. Now, if there is there a case for no redundancy? Is there a case in which redundancy can be 0? What do you think? Well, for redundancy to be 0, it's just the fact that that small square has to be 0. It doesn't matter what is happening in the rest of the table. As long as this small square is 0, then you have 0 redundancy. Again, this is why we think it's quite powerful, because for other methods of assessing the relationship, either association, as we mentioned, but also factor analysis, principal component analysis, they would all consider the whole of the table, but redundancy only focuses on the overlapping deprivations. So in terms of the meaning, it counts the number of observations that have the same status, both deprived, both poor, and it adjusts by the level of deprivation. That is the headcount ratio, either censored or raw. It depends on what you are using on your table. Again, it defines the strength of the relationship as the proportion of poverty matches, the proportion of overlapping deprivations in the lowest level of poverty. So a redundancy coefficient of 0.9 would signal that 90% of the people that are deprived in the indicator with the lowest headcount ratio are also deprived in the other indicator. And as I mentioned, if it reaches 1 or 100%, it means that all the people that are deprived in the indicator with the lowest deprivation are also deprived in the other indicator. For instance, a coefficient of 0.9 would be a very high association. But what can we do, as you have asked many times? Well, first, it is not good or bad on its own. Secondly, it would be good to analyze both Kramer V and the redundancy of both indicators. And then to ask yourself, do we need to keep both indicators? Should we justify keeping one, or shall I just continue justifying my indicators on other grounds? Let's see the example of Mozambique. In the Mozambique DHS data, we have an overlapping deprivation in years of schooling and school attendance. You can see that normally those actually empirically, those two indicators are the ones that show the largest overlapping in the MPI, I can say. You can think that this is probably right because, or this is probably intuitive, because when you have parents or adults in the household that do not complete the 5 years of schooling, then it's very likely that you have children that are not attending school. Still, overlapping deprivation is probably not, or at first eyesight, it's not that high, 16.27%. So when you analyze the Kramer V and consider the whole contingency table, you get a 0.199. But when you consider redundancy, you are only considering the 16.27 in the context of marginal deprivations that ranges from 30 to 38%. So because only roughly a third of the society are deprived in this indicator, actually this 16% has to be put into the context of this a third of the society. And when we put it in a context of the third of the society, then we get that the redundancy of both indicators is 0.5. But we have another counterexample for Bangladesh. Again, we have an overlapping distribution of 5.75%. That seems to be very low, but put in the context of 15 to 19%, the redundancy is 0.37. Whereas the Kramer V or the association shows 0.196, which is very similar to our previous example. So similar associations of Kramer V can have very different measures of redundancy. And this is just basically showing some other indicators, cooking fuel, and how the relationship exists. So the highest redundancy is shown for cooking fuel, but is retained probably under different considerations. Actually, we have seen that cooking fuel is the deprivation that is most commonly existing across countries. For many countries, cooking fuel is the highest deprivation that is experienced, and there is very likely that it shows overlapping, overlap or positive matches with many other indicators. Still, we know that it's very important to retain it because the consequences for health and and for other aspects make it important for it to be kept in the index, and it is not discarded only because of this redundancy. So again, the divergence of these conclusions of different coefficients says that we have a lot of information in the cross tabulation, and the measure of redundancy focuses on the overlap and considers the overlapping deprivations.